Hello viewers, welcome back to my YouTube channel. In the previous class, we have learned about exercise 1.3 and in this YouTube session, we are going to continue with the exercise 1.3 of 9th NCERT Mathematics, that is number system. Let us take up with question number 4. Question number 4 says express 0.9999 in the form of P by Q. Are you surprised by the answer? So let us see whether any surprise may happen or not. We know to get into the form of P by Q, we need to take x is equal to 0.9999 etc etc and multiply LHS and RHS by the factor 10. LHS becomes 10x and RHS becomes 9.9999 etc etc and 10x as it is, and you just split this in 9 plus 0.9999 etc. So you know already this the method of dividing the fraction into the p by q form. To put this, we know already the value of this is x, and put the value of x in this equation, you will get, so 10x minus x is equal to 9. 10x minus x is 9x is equal to 9. X equals to 9 by 9. So I think here you can see, are you surprised by the answer? Yes, because the P and Q both are 9 and the answer would be 1. So that makes sense that 0.9999 equal to 1. So I hope all of you understood this problem. Let us take up with the next one. That is exercise 1.3, question number 5. What is the maximum number of digits b in the repeating block of digits in a decimal expansion of 1 by 17? Students, carefully observe here. You need to do the long division here. So for doing long division, you know already, just put 17 here, and 1 is always less than 17, put 0 point and put 1 0, and again 10 is less than 17, put another 0, it becomes 100. So 17 5s are 85. If you subtract this, the remainder is 15, and put one more 0 since you have taken 0 here. For 17 8s are 136. So that is 14 as a reminder, 140. Again 17 8s are 136. 4 is a reminder, 17 2s are 34. 6 as a reminder, 17 3s are 51. So 9 as a reminder, 17 5s are 85 again, and 5 as a reminder, 17 2s are 34. So 16 as a reminder, and put one more 0 here. 17 9s are 153. The remainder is 7. Again it becomes 70. I'll do here. For 70, you need to take 17 4s are 68. So 2 as a reminder and put 20. 17 1s are 17. 3 as a reminder, put 0 here, 30. 17 1s are 17. 30 minus 17 is 13. Again put 0 here, it becomes 130. 17 sevens are 119, and the remainder is 11, and put 0 here, 110. 17 6s are 102, and the remainder is 8. Put 80 here. 17 4s are 68. It becomes 12, 120 as a reminder, and 17 sevens are 119, and the remainder here becomes 1. So listen here. So you start with 1 and you end up with 1, and this goes on continuous. So again you put 0.00 here, and the same thing whatever there in this block will continue and repeat. So we can say how many digits are there, you just count it. There are 16 digits are there, hence the number of digits in a repeating blocks is 16. So you have to write down the answer. 1 by 17 is equal to 0.0588 235294117647 whole bar, because the whole thing is repeating again and again. So the number of repeat digits in the repeating block is 16. I hope all of you understood this question. Let us move on to the next one. Question number 6. You have to look at several example of rational numbers in the form of p by q, where p and q are no common factors here, and you need to guess what property of q must satisfy. Let us take up some examples for to learn this question. Let us take up 2 by 5. We'll get our answer as 0.4. Let us take 3 by 2. We'll get 1.5 as an answer, and 7 by 8, it becomes 0.875. So remember, I'm doing the all the answers here. You just see all are terminating only. Okay. So now, if you observe all these things, all the denominators are in the form of 2 or its power. Similarly, denominator, that is this thing, or it is 5 its power. So from this we can analyze that we can do one more thing, that is combination of both 2 and 5. Combination of both 2 and 5. So from this we can say that you can see what property of q must satisfy. It should be either 2 or its power, it should be either 5 or its power, or both 5 and 2. Let us take the next question, that is question number 7 and question number 8. Write those three numbers whose decimal expansion are non-terminating, non-recurring. You already studied this, and in the previous video I've explained what is the meaning of non-terminating and non-recurring. You can write any three examples. I just here I'm going to write three examples here: 7.314, 1114, etc., etc., etc. And the second example is 0.10, 100, 200, three four zeros, four, etc., etc. See, you can observe here, these are all non-terminating as well as non-recurring. The value of pi 3.1416, etc., etc., etc. You can write any examples which are irrational, and those are non-terminating and non-recurring. Coming back to this next question, find three irrational number between the rational number 5 by 7 and 9 by 7. So initially you need to find out the value of 5 by 7. If you do the decimal expansion, the answer would be like this: 0.714285 whole bar. For 9 by 11, you will get the answer as 0.81 whole bar. You observe here carefully, the answer lies between 0.71 to 0.81. Take up first two digits and write, because we know infinitely many numbers can be right between two rational numbers. So we can take up any three numbers. I'll write randomly. So 0.72345996, etc., etc., whole bar, 0.742573 whole bar, etc., 0.78123957. So you observe here, first two digits are lies between 0.71 and 0.81. You can see here 0.72, 0.74, and 0.78. I hope all of you understood this question. Let us move on to the next one. The last question of exercise 1.3, that is, you need to identify the given numbers as rational or irrational number. Take up the first one. Say, since 23 is not a perfect square, you can directly write it is a irrational number. If you do the decimal expansion, the decimal expansion would be non-terminating and non-recurring. So 225, it's a perfect square of 50, then it is a rational number. So 0.3796 is a terminating one. We know the definition of rational numbers. The property of rational numbers says whichever the number decimal expansion is terminates, that numbers are called rational. 7.478478. You carefully observe this problem. 478 and 478 are repeating, and it goes on like this. We can write for 0.478478 again at whole bar. We know the property of rational number. Either it terminates or it doesn't terminate, but the expansion is repeating. then the property is rational only. So this is rational. The last problem, that is 1.101.001.0001 etc etc. Since there is no repeating terms here and there is no terminating values here, you can directly say it is a rational number. I hope all of you understood this question. So thanks for watching. Don't forget to like, comment, share and subscribe. Thank you very much.